Welcome to Cavity Trays of Yeovil, the longest established company in this specialized field and the only tray manufacturer awarded European technical approval. This is seminar number 1. It deals with DPCs and flashings necessary to protect a typical cavity wall envelope. It demonstrates how the use of preformed components, now known as cavity trays or cavi trays, can improve the build detail and build quality. Cavity Trays of Yeovil originated as an offshoot of a West Country building contractor. The first tray was conceived in the 1920s, since when the range has been steadily increased. Cavity Trays of Yeovil now offers more preformed solutions than any other organization, as well as a bespoke service for non-standard applications. Products are accompanied with a performance warranty. Before the invention of preformed cavity trays, DPCs and flashings were handled as individual elements. Installation usually involved several trades. The damp-proof course might be installed by the mason, whilst the flashing might be introduced by the plumber. Each was reliant on the other for the accuracy and convenience of placement and fabrication. Preformed cavity trays transformed the practice. Whilst flexible material to form damp-proof courses and form cavity trays in cavities is still permissible, caution is advised, especially if a three-dimensional approach is required. This slide depicts where a flexible material might perform successfully as it is fully supported over a window head. It relies on being built either into the inside skin or mechanically attached to it. Any moisture that penetrates the outer leaf is captured. However, observe, the shape of the DPC drops vertically against the inner skin. Such proximity with the inner skin is best avoided. And as this arrangement lacks the requisite stop ends, water can discharge into the cavity and against the inner skin, which is unacceptable. If the cavity is fully or partially insulated and water discharges into such insulation, the water will saturate and spread indiscriminately in all directions. And this assumes a DPC profile is uniform and correctly shaped. If it's distorted, out of level, or permits pooling water to track back under it, the shortcomings increase. Site-formed DPCs of this style lack stop ends as defined within the regulations. Without stop ends, water discharge into the cavity cannot be eliminated. The use of roll DPC relies on the installer forming the right shape every time. This is why preformed cloaks are often used instead. Preformed cloaks are ideal in many situations, such as at the base of a building, because at the base of a building, both skins commence level with each other, enabling a preformed cloak to sit comfortably in both and provide the requisite profile. But as a cavity wall rises, it is not unusual for the skins to drift out of level. In this example, the cloak profile provides 225 mm rise, but the drifting of skin levels results in the blockwork course being lower than that required by the cloak. The result is a distorted arrangement. When skin levels drift and the measurement by which the cloak rises cannot match the intended inner skin course, then the opposite can happen. Skins drifting out of level is a common occurrence. Look for the telltale signs on site, especially at plate level, where correction is carried out and one often observes an additional course of brick or buttering up of the plate. Many errors can occur on site, and here we have a typical example. This DPC ends abruptly and has no stop end. The tray is also not bedded on mortar, promoting the possibility of capillary and hygroscopic penetration below the base of the DPC. And the use of perforated bricks can pose further problems if water can use the open perfs as vertical conduits via which to gravitate. The outer skin of a cavity wall is designed to saturate, and the cavity ensures the inner skin remains dry. But in the case of stepped and staggered gable abutments, the need for damp arrestment changes. The outer leaf above the finished roofline becomes an inside wall below it. There is a requirement to arrest the dampness from gravitating downwardly in the same skin and permeating below the roofline. This is an attempt to provide arrestment that failed. The DPC profile is irregular, distorted, and continues too far into the roofline. The DPC front edge terminates too far back from the finished face, whilst the entire arrangement lacks mortar. It is dry-bedded. The external flashing does not unite correctly with the DPC to provide uninterrupted linked protection. This view into a typical cavity shows what can happen using standard rolled DPC to create a stepped arrangement for a sloping abutment. The DPC profile is irregular and badly formed, and there is no vertical continuity between each section. We are looking from the inboard end nearest the roofline, and there are no stop ends. The DPC is open-ended. Water arrested can discharge at either end. There is no guarantee where it will discharge and where it will land. Where DPCs and trays require flashings, it is essential the two interface correctly. In this instance, a cover flashing has been introduced, but incorrectly. It is positioned above the DPC, resulting in arrested water being able to permeate under the flashing. Flashings, if introduced separately, must terminate under the DPC and do so to a depth and lapping compression that provides a watertight relationship. This extract from the NHBC standards shows the relationship required to form a satisfactory union between flashing and DPC. The mortar below the cavity tray DPC is raked out while still green to provide the required recess. The flashing is inserted and wedged. The union is subsequently pointed in. Importantly, this approach assumes that DPC is correctly positioned in the first instance. If the flashing is a running flashing as opposed to a lap flashing formed with separate pieces under each DPC tray, be aware that a running flashing cannot provide weathering protection to the same extent. A lapped flashing offers greater protection and is always preferable. Raking out under the DPC was not possible in this example, as there was no mortar underneath. The DPC had been dry-bedded. The attempt to provide a slot for the flashing damaged the DPC edge. The resultant installation was unsatisfactory for 3 reasons: dry bedding, damaged DPC, the flashing ended up on top instead of underneath the damp course. Since the founders of the company, now called Cavity Trays Limited, created the first cavity tray in the 1920s, the expertise and understanding of the current company has grown. The company has a lengthy and proven track record unequaled by any other organization within this specialized field. Approved products of Cavity Trays Limited are referred to as cavity trays or cavitrays. They are all accompanied with a performance warranty. The first preform cavity tray or cavitray designed for stepped and staggered gable abutments is the Type X. The Type X is a preformed DPC tray specifically made for stepped and staggered gable abutments. It is molded from pethylene DPC and supplied with its own flashing already attached. Type X trays are built into the outer skin only just above the abutting roofline. The interconnecting trays arrest the cavity wall, water flow and dampness and prevent it from gravitating downwardly below the roofline. The integral flashing of each tray eliminates the need to cut and rake out for flashings. Following building in of the trays, the DPC and flashing installation is complete. Later in the build program, the flashings are dressed. Type X trays are available to suit all roof pitches, masonry finishes, and masonry dimensions. Manufacturing the Type X from pethylene produces a durable preformed tray that does not require support from the inside skin. The cavity upstand is self-supporting and it is hinged. It adjusts to suit the cavity width encountered rather than the cavity width intended. This ensures compatibility. The as-built width is always protected. Standard trays accommodate cavity widths from 50 mm up to 140 mm. Bespoke trays are available for wider cavity widths. The section of the tray that projects into the cavity is called the cavity compartment area. It is purposely manufactured free from projections or protrusions around which mortar droppings might become trapped. The clear cavity compartment is important and aids free discharge of arrested water. Type X trays are installed in every course. Each tray up the slope oversails the tray beneath it. A protective DPC staircase arrangement is created with connecting treads and connecting risers. The flashing of each higher tray also overlaps the flashing of the tray beneath it. This results in unpunctuated DPC arrestment through the external skin and cavity just above the roof intersection. The attached flashing provides overlapping weathering protection that can interface with the abutting roof finish. The standard flashing material is Code 4 milled lead. Code 5 lead is also offered, or one may select from alternative options, including a synthetic flashing with BBA certification. Arrested water cascades from one tray to the next. It is usual for the bottom tray to be a catchment tray. A catchment tray has upstands at both ends and therefore collects the water. Discharge of the collected water is directed through a cavi-weep built into an appropriate perp joint. Accurate installation is straightforward and easily accomplished. The mason provides a chalk line or dummy rafter 75 mm off the finished roof line. As each tray is bedded, its corner is positioned on the 75 mm line. This ensures optimum placement. This positioning of trays and flashings creates a continuous staircase arrangement with connecting treads and connecting risers. Full installation instructions are supplied with each delivery. Trays are supplied with flashings bonded within a bosom integrity jaw. Flashings are available in two styles, long flashing or short flashing. Short flashings are proportioned to dress downwardly over the upstand of a secret gutter or soaker. Long flashings are proportioned to dress downwardly and then across a profiled tile. The specifier may select whichever option is appropriate. Traditionally, most flashings are of Code 4 lead, but a synthetic substitute is available for use where there are theft concerns. There are also some metal alternatives for specific applications where there are aesthetic or compatibility issues. For instance, copper flashings can be supplied for copper roof abutments. This is an example of cavi trays supplied with copper flashings. In this instance, a curved, vaulted roof abuts with a roof finish also of copper. This is an example of a profiled tile over which the flashing can be directly dressed. Thus, Type X trays with long flashings are appropriate. Trays are handed and identified left or right. The bottom of the slope commences with a catchment tray with cavi-weep. Intermediate trays are built into each course up the slope of the roof. A ridge tray straddles the ridge. The ridge tray is able to discharge at both ends into the trays below. The type and material used to construct the inner skin does not affect the Type X tray or its functionality. The self-supporting cavity upstand can always take up the maximum cavity width regardless of the type of inside skin. If that cavity width varies, the Type X adjusts accordingly. Trays may be used with compliant partial or full fill insulation. Two further benefits previously not mentioned include the corner gusset to the front of every tray. This prevents water discharge at the inboard end corner. It also assists the mason. The gusset locates against the front face of the masonry, so it stops the tray being incorrectly located too far back. Similarly, it prevents the tray from being bedded too far forward, as it would stand proud from the masonry face. Underneath the tray base are drip bars. These assist by ensuring water always discharges from the tray even if it attempts to track back underneath. They also assist when bedding the tray, as they permit the mason to bed the tray down on the mortar until the bars make contact with the masonry underneath. When they do, the bed course is of optimum thickness. The individual lapping flashings of the Type X provide far more resistance to wind-driven rain compared with a conventional running flashing. When rain is blown under the leading edge of a conventional running flashing, it is immediately in contact with the masonry under that flashing. Even if there is a secret gutter or soaker in position, it does not extend to where the flashing leading edge emerges from the wall. This is the area of weakness via which wind-driven rain can permeate inwardly and downwardly. In contrast, the flashing on every Type X tray laps with that of the adjoining tray. Wind-driven rain is arrested by the next layer that isolates the wetness and prevents it from coming into contact with the masonry fabric. Cavi-tray overlapping flashing is another aspect of the Type X tray not replicated by any other manufacturer. This is a typical example of a running flashing that does not offer the same degree of weathering protection as overlapping flashings. Consider where wind-driven rain that penetrates the angle leading edge ends up. The height of any soaker or secret gutter under it is inadequate to stop water soaking into the masonry and gravitating below the roofline. Note also a bitumen-based DPC has been used in this construction, and already it is seeping, exuding under load. Here we look at all the tray types that make up the standard range. At the bottom, we have the catchment tray. It is the first tray to be built in. It resembles an intermediate tray, except it has two ends, so it can collect the water for discharge via a cavi weep. If the bottom of the tray rung coincides with the corner of a building, instead use an external or internal angle tray. Angle trays have the advantage of extending DPC protection around the corner. They also provide a means for any horizontal tray arrangement that may be present to link up, as indicated in this illustration. The trays that are then built into each course and make up most of the installation run are intermediate trays. These continue until the ridge is reached. The ridge tray straddles the ridge and discharges from both ends into the intermediate trays. Cavity Trays Limited operates a full takeoff service. If you wish us to calculate your exact requirements, we are delighted to do so. Trays are available to suit walls of all styles, thicknesses and masonry styles, whether straight, concave or convex. In every application, the end upstand of each tray matches the coursing height of the material used to construct the exterior skin. The tray configuration replicates a DPC staircase with connecting treads and connecting risers. Consider standing at the foot of a staircase with a bucket of water and throwing it onto the stairs. The water cascades downwardly from tread to tread. The same bucket of water thrown onto an open-plan staircase will go between the treads. Similarly, water will track between, into and below the roofline if the upstand protection is inadequate or missing. Cavity Trays Limited calculates your requirements to ensure this aspect, as well as many other considerations, are taken into account, regardless of whether your wall is straight, concave or convex. Curved structures provide an interesting anomaly. Despite the pitch of the roof being constant, the angle at the point of intersection can be different at almost every course. Requirements for curved structures are computer generated, and take into account the varying requirement at each course level, as well as other factors. One such consideration is increased water wash that accumulates away from the direction of the prevailing wind when gravitation overpowers the suspension of volumes blown around the curve of the wall. This places increased demands on flashings. Cavity Trays Limited calculates these requirements and submits proposals for your perusal. This is a non-standard situation where a sedum roof abuts a wall. Bespoke trays were supplied at the roof junction intersection. The project required trays to suit an exterior skin that was both concave and convex. The flashings of each tray varied in shape to accommodate the rise and fall of the wave roof. All calculations were prepared by Cavity Trays Limited, and trays numbered so the mason simply sequentially built in. This is a property built using natural hamstone laid in 225mm coursings. The cavity trays are proportioned to accommodate the stone course height and the stone thickness. Such trays are often referred to as multi-course cavity trays. Approved preform cavity trays are available to suit all masonry styles and dimensions. This demonstrates how multi-course trays are located. Note the trays are always bedded on mortar. Installation is the same for brick, stone or block. In addition to new build application, preformed cavity trays may also be inserted into existing wall. This might be to remedy an ongoing problem or to introduce compliant dam protection when an extension is attached to an existing structure. In this instance, just a couple of bricks removed from one course provide a sufficient opening. Type X trays are used to remedy NHBC claims where previous attempts to provide DPC compliancy have failed. NHBC standards stipulate a conservatory attachment should comply with the building regulations. The NHBC provides guidance showing tray installation. Whether used for new build or existing remedial applications, the width of the cavity should never be assumed. The adjustable cavity upstand ensures compatibility without demands to punctuate nor disturb the inside skin. While standard trays will adjust to suit a cavity of 50mm to 140mm, non-standard options are available for all dimensions. And if the cavity has projections or column protrusions, we supply solutions to navigate around them. At all times, dam protection status is maintained. Remedial work is usually carried out on sites where either no trays have been fitted or the use of floppy raw material has proved inadequate. In this example, the contractor departed from the original specification of the architect and did not install Type X trays. Instead, an alternative proprietary make was installed. But not all trays are the same. The builder's choice proved an expensive one. The arrangement did not prevent dampness entering the new library beneath the sloping roofline. The unsatisfactory installation was removed and the originally specified approved Type X trays installed. The damp problem ceased. Specification switching can be both costly and embarrassing for the contractor. Existing installations that fail to arrest penetrating water often share a number of common weaknesses. It might include a suspect relationship between the DPC and the flashing. That was the problem with this further example that suffered capillary seepage because the DPC was inadequately formed and distorted. Where Type X trays are installed in an existing wall to regularize the construction, the procedure is repetitive and sequential. Note how the upstand always adjusts to suit the as-found cavity width. Where a cavity party wall rises above the roofline, a different approach is required. In this instance, both roofs are at the same level. The trays are manufactured to dimensions that permit them to be used back-to-back and linked at the top. This establishes DPC integrity to both skins. With both parapet skins being external, this approach prevents wetness from coming into contact with the backs of the upstands. This applies only if the roof levels are identical. Cavity Trays Limited is the only manufacturer in Europe to hold European technical approval for products within the specialized field of cavity trays, temp courses and flashings. Our approved products are additionally accompanied with a performance warranty for the benefit of architect, builder and client. We recommend study of BS 5628-3 2005 that includes reference to the correct use of cavity trays on page 63. This is an extract from BS 5628 courtesy of British Standards. We now look at horizontal abutments. The tray type for horizontal abutments is called the Type G cavity tray. With a similar profile to that of the Type X, Type G trays have an adjustable cavity upstand and integral stop ends. They are supplied in brick module lengths, the most popular being 90 mm, 675 mm and 450 mm. Adjoining lengths simply interlock together utilizing the integral stop ends. So long runs can be created that really consist of a number of connected trays. Type G trays can be supplied with or without an attached flashing. The Type G most used on sites has a flashing of 150 mm of code 4 lead. Other flashing lengths and types are available. The flashing is extended beyond the end of each tray, so when adjoining trays are clipped together, the flashings lap appropriately. Laying of trays onto mortar proceeds from left to right. The tray end upstands coincide with the perp joints, so the bonding pattern need not be altered. Water arrested within each tray is evacuated out of the wall via caviweeps. These are incorporated within perp joints towards the center of each tray. Long runs of tray are really a series of standalone yet attached self-discharging units. This shows the use of Type G cavity trays in a typical application. Here, Type G horizontal trays with 150 mm lead flashing attached provide protection along the top of the tiled roof. In the corner, a Type G angle has been incorporated that continues the protection along the adjacent wall. Immediately under this angle, Type X trays are located. The sloping and horizontal runs ensure wetness is arrested and the water discharged via caviweeps built into perp joints. The variable back upstand is designed for the as-built rather than the as-intended cavity width. Standard Type G trays can service cavity widths from 50 mm up to 160 mm. non-standard upstands are offered for wider cavities. As each tray is bedded on mortar, the end upstand and the back upstand link with those on the adjoining tray. This results in a continuous protective arrangement, a typical Type G installation, in which the trays have been bedded and await subsequent laying of masonry. Note how the adjustable upstand has accommodated with cavity width encountered. Type G trays are designed for new work applications. As with the Type X range, we can supply models with different base and length dimensions to suit your masonry module and bonding. Type G cavity trays provide the horizontal intersection arrestment solution in new build applications. For existing structures, an alternative is available, the Type E. The Type E tray is similar to the Type G, but is specifically designed for insertion into existing walls. It is a tray for horizontal insertion into existing cavity masonry above the roofline of the new extension or conservatory room. It is also regularly used in remedial applications where an existing DPC has failed. Here are two typical examples. Underneath the new roof, the original outside wall of the property becomes an internal wall. There is a requirement under building regulations to prevent water that penetrates above the roofline from gravitating below it. Water permeating the outer skin must be prevented from tracking downwardly. A flashing only is insufficient to stop ingress. When inserted into the masonry, the Type E can prevent downward travel, in a similar way to the previously described Type G. The difference is the Type E is manufactured in short lengths, so the existing masonry can be cut out progressively, and the short, interconnecting Type E lengths introduced with a minimum of disturbance to the structure. Each standard tray is 450 mm in length. Removal of just 3 bricks provides a working opening. Into this opening and onto mortar bedding, along which a separate flashing is unrolled, is located the first Type E tray. The video that follows demonstrates how a 3-brick opening sequence is repeated and the flashing unrolled to progressively create a protective long run. Installation is normally from left to right, and masonry is mortared and wedged back into each tray before the next tray is started. A cavi-weep is introduced into the most central perp within each tray to provide an evacuation route for the arrested water. Standard internal and external angles permit any run of trays to turn corners. Special angles and infill lengths are available to address bespoke requirements. All tray dimensions are variable, so if the existing masonry skin calls for trays of a greater depth, length or height, an appropriate tray can be supplied. The intersecting concrete can act as a bridge via which penetrating water can track towards the inner skin. This occurs where no DPC provision has been built in or the existing arrangement has failed. Type E trays can be introduced to remedy the problem. In such applications, a flashing is not normally required to be introduced under the tray. The tray is directly bedded. Interestingly, this type of construction is technically flawed, as it relies on water not permeating the exposed cast concrete face. This is why the exterior face often receives some form of finish or treatment to act as a Macintosh and prevent permeation. The end upstands of the Type E ensure integrity is maintained where the end trays abut any vertical columns. At all times, the front lip guards against wind-driven rains challenging the bedding course, as it is covered. Type E installation sequence, working from left to right, utilizing a cover flashing, weeps and slate pinning as required. Note the ability of the back upstand to adjust to the as-found cavity width. In normal applications, just one course of masonry need be removed. Here we see the flashing awaiting subsequent mortar and tray bedding. We recommend a 3-brick opening is optimum for progressive insertion of trays. Cavity weeps are seen here incorporated in the most central perp of the masonry within each tray. The cavity weep colour can be chosen, the most popular being grey, as it visually merges with the mortar colour. Typical example of Type E cavity trays installed in a hotel in Essex, used in conjunction with a lead cover flashing. A decision was made here to remove 2 courses rather than 1, as the cavity was discovered to be rather choked. The flashing in this instance is larger than one would normally use, apparently to link with a specific roof style. This wall is curved on plan, and attempts by the site operative to use roll DPC resulted in puckered edges along the curves. These interfered with the uniform laying of the brickwork, so the mason cut the puckers off. The arrangement failed to prevent wet ingress. Modified curved Type E trays were supplied to replace the failed roll form material. The structure dam problems were immediately eliminated. Designers should be aware the use of roll and sheet material in practice rarely results in a consistent profile and quality of build. Apart from the difficulty of introducing a functionally efficient profile into an existing cavity, the linking of adjoining sections and the uniform creation of stop ends is rarely dependable. Such concerns can be witnessed here, where despite the wall being rendered, the amount of wind-driven water penetration was extensive. If an installation relies on an operative with a roll of DPC material and a craft knife working in site conditions, the outcome is usually questionable at best. The following pictures are some examples of what can go wrong. Poor installations create problems. They do not solve them. Flashing only an intersection is insufficient. We are uncertain what the operative was trying to achieve with this arrangement that has no less than 6 irregularities. DPC trays for use over common openings are called Type C cavity trays. Type C cavity trays are preformed, protective DPC trays supplied to harmonize with a support arrangement over the opening. They are available in an unlimited variety of profiles to suit all lintel types and all construction dimensions. Using a preformed tray ensures the build detail is correct and consistent. The dangers of distortion, misplacement, sagging or incorrect profile associated with floppy roll DPC need not arise. Trays suit traditional and timber frame construction. Wastage can be eliminated, while stock and cost control can be accurately maintained. Trays are supplied in lengths to suit the opening, with sufficient end projection into the masonry to provide the requisite protection over the reveal closing. The specifier may select a self-supporting upstand as shown, or an upstand that additionally returns into the inner leaf. Both options are available in a profile to suit the specifier's opening support arrangement, being it utilizing metal, timber, or concrete lintels. Current directives prohibit the discharge of water off the end of lintels and DPCs into the cavity. The use of stop ends addresses this requirement. This is an example of the Type L stop end that can be attached to our preformed Type C cavity trays. The integral bonding strip in its base permits the installer to position it in the most appropriate perp joint towards the end of the tray. Thus the bonding remains unbroken. 2 styles of standard stop end are manufactured. The L90 is suitable with vertically rising profiles. The adjustable Type L is designed for use where the DPC tray upstand is sloping. Not all openings in cavity walls have a horizontal head, and to conclude, we look at some variations. Type BA barrier arch trays are preformed to suit the specific opening dimension and can be used in conjunction with a metal curved support lintel or alternatively incorporated within a traditionally constructed arch built off timber centering. The tray can be built into the inner leaf or attached to it aided by a cavity strap. Thus, Type BA barrier arches may be used in timber frame as well as conventional construction. The rise of the arch dictates the dimensions of the cavity spanning section, whilst the overall width of the Type BA can be extended beyond the actual opening size to an extent to unite with adjacent features where required. This is an example of a three-centered opening. Trying to achieve the same using raw material would be challenging. The advantage of using Type BA barrier arches becomes more apparent when styles of this nature are encountered. Type BA arches are manufactured from pethylene and are accompanied with a performance undertaking. Finally, where the opening becomes circular, the Type K cabbie tray is supplied, providing 360-degree protection. It glove fits the circular frame, establishing a protective presence between frame and damp masonry. It prevents dampness from reaching the inner skin whilst channeling water safely around its exterior. Along the bottom of the Type K is an integrity flap that ensures water that navigates and naturally gravitates to the 6 o'clock position cannot track back into the structure. Type BA is available to suit the dimensions of the specific circular frame and whatever style of masonry skin permutation is being used. An insulated surround is offered as an attachment. This brief presentation has only scratched the surface of the numbers and types of products available from Cavity Trays Limited. For damp courses, cabbie trays, cabbie closers, membranes, contaminated lamb barriers, fire and acoustic stops, and ventilation for roofs, walls and floors, all such information can be found within our latest technical manual. Approved products and an accompanying performance warranty for the benefit of architect, builder and client. Cavity Trays Limited, for the protection of the building envelope. If you require assistance, please contact our help desk. Technical managers will visit by appointment. Thank you for visiting this Cavity Tray learning module.